Hello, welcome back again to the Bermatematika channel. On this video we are going to discuss the following problem. We have a system of equation which consists of three equations. So we are looking for find all x, y, z that satisfies this system of equation. Okay, so before we get started, you may want to pause the video and give it a try first. So you may pause the video right now. Okay, we start with making a substitution. Let us call u to be x plus y plus z, v to be xy plus yz plus zx, and w is equal to xyz. So we know that xyz is equal to 1, which means that w is equal to 1. And recall that one of the given information say that twice of x squared plus y squared plus z squared is equal to this. So we would like to rewrite this information in terms of u, v, and w. So first let's switch the position of this equation. So it's going to be the same, just rewrite 3 of this equal 2 of that, so like that. And then we can rewrite x squared plus y squared plus z squared as x plus y plus z squared minus twice of v. So therefore this expression, if we multiply by 2, we get the following, right? Okay, so this one is u and that one is v. So we have 3 of this is equal to this minus that. Notice that we can move this expression to the left hand side together with this expression to get 7 of that. So we have 7 of v is equal to 2u squared. So you write it down as 2u squared is equal to 7v. Okay, now use another information. We have used this one, but we haven't used the first equation. So how can we relate this first equation into some expression containing u, v, and w? So notice that we can get this type of expression by raising x plus y plus z to the third power. So let's go ahead. So if we do x plus y plus z to the third power, then we can expand into this expression. Well, this is not really that difficult. You may verify this by, let's see, for example, that you know how to expand a plus b cubed into a cubed plus 3a squared b plus 3ab squared plus b cubed. You can use that information by considering this x plus y as the first term and then the z as the second term. So you can use raising to the third power of a binomial, and then you will get this kind of expression, right? So if we look at this statement carefully, we have that this guy is 73 over 8, so we can replace this by 73 over 8. This one is v, that one is u, and this xyz is w, which is equal to 1. So then we have u cubed is equal to 73 over 8, 3vu minus 3. And then we can simplify further the 73 over 8 minus 3. This is nothing but 24 over 3. So this minus that is going to be 49 over 8. So we have u cubed is 49 over 8 plus 3uv. And we also have 2u squared equal to 7v. So we would like to find out what is u and v from these two informations. So let's take a look how we relate these two equations. So for example, let's rewrite this equation so that we are not involving fraction on the equation. So multiply both sides by 8, we get 8u cubed is equal to 49 plus 24uv. Okay, now how can we get 8u cubed from the first equation? We can multiply the left hand side by 4u, right, to get 8u cubed. So if we do so, then the left hand side will become 8u cubed, and the right hand side, when we multiply this by 4u, we get 28uv. So from these two equations, this and that, we conclude that the right hand side is equal to the right hand side of that equation. So 28uv is equal to 49 plus 24uv. So subtracting or move this to the left hand side, we get 4uv is equal to 49, then multiply by 6. Why we do so? Because we want to replace this 24uv by 6 times 49, right? So if we replace this by 6 times 49 plus 49, that's become 7 times 49, which is 7 times 7 squared. So this is 7 cubed. So 8u cubed is equal to 7 cubed. Therefore, u is equal to, notice that this is nothing but 2 cubed, right? So u is 7 over 2. Okay. Now substituting this u into this equation, we obtain v equal to 7 over 2. We can easily verify that this is correct by noticing that u times v gonna be 49 over 4 multiplied by 4 is indeed equal to 49. So we have u equal to 7 over 2, v equal to 7 over 2, and w is equal to 1. And we rewrite it as follows. So this guy is 7 over 2, that guy is 7 over 2, and the last one is equal to 1. So notice that this u, v, and w is the elementary symmetric polynomial, right? So when we make a polynomial where the roots are x, y, and z, then this xy this u, v, and w appears as the coefficient of s squared, s, and the constant. So the coefficient of s squared is minus of u. The coefficient of s is the coefficient, the coefficient of s is exactly v, and the constant is negative w. So then we have this polynomial. So what this calculation means is that x, y, and z is exactly the roots of this polynomial. But notice that we can easily verify one of the root of this polynomial, namely s equal to 1. So if we plug in s equal to 1, this will cancel with that, and this will cancel with that. So indeed that s equals 1 is one of the root. How we can get the other two roots? We can just divide this polynomial by s minus 1, and we obtain a quadratic equation as the quotient, which can we factor further. So therefore, if we do so, we have this kind of factorization. We can verify by using Horner division or just the regular polynomial division. To divide this polynomial by s minus 1 to get a quadratic polynomial, which can we further simplify and factorize into s minus 2 times s minus 1/2. So remember that xyz is the root of this polynomial. So then therefore xyz is 1, 2, and 1/2 in a certain order. So one possibility is x equal to 1, y equals to 2, and z is equal to 1/2. Okay. Now we need to check explicitly that x, y, z equal to 1, 2, and 1/2 is indeed the solution to this equation. For example, if we plug in this 1, 2, and 1/2 to x and y, so this is 1 cube and 2 cubes, gonna be 9. 9 times 8 is 72, and this is 1/8 plus times 8 is 1, so 72 plus 1 is exactly 73. And you can check for the remaining equations that this 1, 2, and 1/2 is indeed a solution to this equation. Notice that each of this equation is a symmetric equation, which means that if we permute the x, y, z, there is no change in the equation. So that tells us that if we have one solution, then any permutation of that solution is also another solution. So therefore, not only we have one solution, which is 1 and 2 and 1/2, but every permutation of these numbers is still a solution. So in total we have 6 solutions, namely the permutation, all permutations of 1, 2, and 1/2. So that's all the solution to the original equation. So that's all. Thank you for watching. See you again on the next video. Bye bye.